Good afternoon. Hope you are doing well. Today we will be tackling the topic of classes and objects for the second time. Thus, let me recall what we did so far, and we want actually to go further into advanced topics about classes and objects. Okay, last time we implemented a class person, and a class is, as I said actually before, is just a factory of objects. That means in this case, the first thing we have actually to do is to define the attributes of the person object. Thus, I know exactly that every person is having a name, age, and gender. Then the second part was, let's say, we needed the machines just to be able to create the objects, and that's why we implemented something called constructor. It looks like a method, but it's not a method, because once you implement a method, you need either to return the data type of the variable, or of, let's say, the result that you want actually to return. And if the method doesn't return anything, then you need actually to write the keyword void, meaning actually the method is an empty one. However, a constructor doesn't have neither a return type nor actually the void keyword. Last but not least, we implemented some of the methods. We implemented two types of methods, static methods as well as instance methods, just to be able actually to describe the behavior of objects in Java. Okay, let's go back and let's take a look at the constructor. Now, once you take a look at the constructor, we will see that we are using here in total 6 variables. Okay, the name and the age and the gender corresponds to the instance variables of the object I'm creating. N, A, and G corresponds in this case to the formal parameters of the constructor in this case. And that's actually the first question is it possible to change N by name, A by age, and last but not least, G by gender? Okay, now we will try it out. And then actually what we need actually to do here is we need just actually to write, instead of name is equal to N, is name is equal to name, age is equal to age, and gender is equal to gender. Okay, once we do that, if I will compile, then actually this one will compile correctly. Okay, however, the question is now this name. Okay, does it correspond actually to the name, which is the instance variable of the object that I'm creating? Or does it actually denote, in this case, the formal parameter of the constructor? Okay, well, we will look at, let's say, what the main method will return. In this case, if I will get as the, let's say, as the following a main method that is creating two persons, P1 and P2. And last but not least, I will implement, or I will write a print line statement that will print actually P1. Keeping in mind that I have a toString method implemented in the class in order actually to display the name, the age, and the gender on the console. Now, once I will compile, Java will compile, let's say, the code correctly. Once I will run, what I will be getting here in this case, the following. Okay, I'm expecting to get mean at 22 and M. However, due to the fact that Java will get confused in terms name is equal to name, age is equal to age, and gender is equal to gender, which is actually the one that I have in my constructor, what will happen in this case? I get, let's say, that the name will correspond actually to the default value. Okay, that means actually the name will correspond to the default value in this case, okay, which corresponds to, since the name is a string, and the age, you will get actually the age. I changed actually the age to be equal to 22, and that's why what I will receive here is actually the default value in this case. Now, if I would have actually removed actually this one, then what I will be getting now is just null and then 0, because the string is an object. The default value of an object is null. An integer is an age is an integer. The default value of an integer is age, and the gender is a character, and the default value of this one is the escape character space. Okay, thus the question is, I would love actually to solve this problem, and the problem actually lies in the following, that whenever Java sees name is equal to name, what it does is it takes actually the formal parameter name and assign it actually to be the formal parameter name. That means it doesn't actually do anything, and it doesn't change the identify the value of the instance variables of the object that I'm creating. Okay, now the question is, I would love actually to distinguish between actually these two identifiers. Okay, I would love actually to say the name, okay, that I see to the left corresponds actually to the name of the object that I'm creating. And the name that I see to the right corresponds actually to the formal parameter, okay, that I am passing actually to the constructor in this case. Thus, what I need to do is, I need actually to give a name to the object that I'm creating. And since I don't know it, okay, Java actually has, let's say, the default actually value, okay, or the default identifier of the object I'm creating actually to be this. Thus, once I write this dot name, it means in English the name of the object that actually the person constructor will be creating. And last but not least, once I see, let's say, this dot h equal to h, then this dot h means is the instance variable of the object that I am creating, and to the right you see h, well h actually corresponds in this case to the formal parameter that I am passing. And last but not least, the this.gender equal to gender has to be written in order actually to state the following, that the gender corresponds actually to the instance variable of the object that I'm creating. In this case, actually it's the this. Now, the nice thing is, once you will compile and you will run, the problem will be solved, and the name Mina will be displayed, the age 22 will be displayed, and last but not least, M, which is corresponds actually to gender, actually will be displayed in this case. Okay. Thus, there is actually a convention in Java, and the convention is the following. If I want actually to create a constructor, then it would be nice, let's say, to have as an identifier the same identifiers as the instance variables. However, whenever I do that, what I need actually to do in this case is to distinguish between, let's say, the name to the left-hand side of the assignment and the name to the right-hand side of the assignment. Now, again, if I do it, then I have actually to state the following. The name corresponds to the name of the object that I'm creating. LH, since there is no conflict, I don't need actually to write the this, but you will see it in a few minutes. Usually, I will always actually do it to make sure that the H to the left of, let's say, this assignment corresponds to the instance variable, okay, of the object that I'm creating. Now, if I will go down and I will just create a second person, in this case without an H, thus in this case I will print it actually with P2. Once I will compile and you will run, this is actually the second constructor. The second constructor takes only 2 parameters. However, every object I'm creating is having 3 features. The first feature is the name. The second feature is 29, since actually the 29 is, let's say, the frozen value of the variable of the age. Okay, this one actually will be always displayed if I'm using actually the second constructor. Now, if I will go back and I will write here, this dot age is equal to 29, everything actually will work perfectly, and Java will understand that what I am having actually to the left corresponds actually to the instance variable of the object that I'm creating. What I am having actually to the right corresponds either, in this case, to the formal parameters that I am passing actually to the constructor, or in this case to the value, which is actually the literal actually 29. Okay, thus, having said that, the this corresponds always actually to the object that I'm creating. The this actually corresponds, in this case, if I will go actually to an instance variable, okay, is I want actually to know, let's say here, which name I am returning. I am returning the name of the object that I will be invoking the getName method on. And this one actually, it's having actually this dot name. Java will include it automatically for you. Okay, now in this case, if I want actually to go down and test actually the getName, then in this case p2.getName will be, let's say, a method. It's an instance method invoked on p2, and what I will be getting here in this case is, let's say, the information about let's say Sarah, who corresponds actually to the name of P2 in this case. Now, let's go up to the method, which is actually the instance method setName. Okay, now once I will go to the setName method, let me go there. The setName method is having as a formal parameter for, let's say, as an identifier for the formal parameter, and that's what I can do is I can replace it actually by name. However, here Java will get confused. If I will write name is equal to name, the same problem that occurred in the constructor will happen now, and that's why I have always actually to, let's say, distinguish between the identifier that corresponds to the instance variable versus the identifier that corresponds to the formal parameter. What you see on the right, okay, without using this keyword, is the identifier of the formal parameter in this case, which corresponds actually to this name. The question is to the left. What do I want actually to do? I want to set the name of a specific person. And this specific person is having as a name this. Now, you will see what will happen in this case. If I will go to the method, and Sarah would love actually to change her name, what I will do is I will go and write p2.setName. Okay, in this case, Sarah wants actually to change her name to be Maria. Okay, and now you will see exactly what will happen. Once actually I will compile, it compiles correctly. Once I will run, I will be expecting actually to get as a result Maria, and you get as a result actually Maria. In this case, the method actually worked properly in this case. Okay, now let me go up and let's implement actually first a static variable to compare two persons. Okay, that's as you saw before, I will be implementing a method. The method will return a Boolean value. It's called compare, and it compares actually two persons, person P1 and person P2. Just actually keep in mind what I am actually doing here is doing here is just actually to define, let's say, to write actually the signature of the method. It's a static method, meaning I will be passing the parameter for the compare method actually to the method itself, meaning in this case I will always call it with compare person 1 and person 2 in this case. Now, assume I want actually to do the following. This should return actually true if the age of person 1 is greater than the age of person 2. And that's why what I will do is, I will take actually p1.age greater than p2.age in this case. Okay? Thus, if I have that, what I want actually to do is, I want actually to check it. Thus, I will just go down. I have actually two persons. One of them is, let's say, using this first constructor. The second one is using actually the second constructor, okay, where actually the age will be equal to 29. And what I want actually to do is, I want actually to run actually the compare on P1 and P2. Okay, thus I know exactly that the age of P1 is smaller than the age of P2. That means I will be expecting here is false. Okay, and what you get actually as a result is false. Why? Because the age of P1 is not greater than age of P2. Now, if I will swap actually the P1 with the P2, then in this case, for sure, I will be getting true because P2.age will be 29. P1.age will be equal to 22, and what I will be getting as a result here is just a Boolean expression that will actually return for you true in this case. Okay, nice. This is now a kind of static method. Okay, now the question is, if I want to implement the method as an instance method. Okay, thus what I need actually to do is the following. Let's actually take a look at, let's say, the method itself. Now, just actually I will show you again how you will go from a static method to an instance method. The first thing is you are not allowed actually to use the static keyword anymore. Thus, the method will be having an access modifier public, meaning everyone actually will be able to access it from outside. Then I will be having a compare. And just actually keep in mind, at the end of the day, the compare will be just a method where I will be passing one parameter and I have to invoke it on another parameter. Okay, and that's why what will happen in this case, if I see compare P1, compare P2, okay, what will happen in this case, I will keep only the second one. Okay, thus I will call person of P. Okay, and now what I will be returning is the following. I will return the name, okay, which is greater than P dot name in this case. Okay, thus the question is the name. Is the name of whom? This is the name of the object that I will invoke the method on. And as we saw before in the setName method, as well as in the constructor, the name corresponds to the name of the object that I will be invoking the method on. Now, the only difference actually lie in the way how you will actually call it. Thus, in this case, if I have here P2, okay, and I want actually to call the one which is the instance method that takes only one parameter, which is actually the person, you have always to invoke it on, let's say, P1 in this case, which is another person. And what you will be getting here is, since actually the age of Mina is not greater than the age of, let me compile, there is a small problem, okay? It's the operator, it's not actually the name, it's the age, sorry about that. Thus, it's actually the age. Now, once I will compile and I will run, what you will be getting as a result is false, okay, which corresponds actually to this same result that we got actually before in this case. Why? Because I was invoking, let's say, the method compare on P1, okay, and passing the parameter P2 in this case. Thus, I will be comparing P1.h greater than P2.h, when in this case it doesn't actually, it's false. Now, if I will do it with P2.compare P1, in this case, once I will compile and you will run, what you will be getting here is true. Why? Because the second constructor will freeze the value of the age to be equal to 29. 29 is greater than 22, and that's why you get as a result a true in this case. Okay, thus, this is the first use of the keyword this. Okay, thus, in this case, what I will be doing here is the following. If I will remove it, Java will not complain. Why? Because I don't have any conflict. If I see age, I know exactly that the age corresponds to the age of the object I will be invoking the method on. And that's why once I will compile, this one will compile correctly. Java will include to the age this dot age, and it will give me actually the same result in this case. Okay, thus, this is actually the first use of the this keyword. Now, let me go to the constructors again. Okay, thus, what I'm seeing here is a constructor, okay, two constructors. One of them is initializing a name to be equal to this dot name, and age to be equal to this dot age, gender is equal to this dot gender. Unfortunately, once I will go actually to, let's say, this part, I will be getting, in this case, the same statement actually written once. Thus the question is, okay, we know actually really how to avoid writing the code over and over again, and that's why I will comment it. Now the question is it possible to use the first constructor in this case and pass as parameter name 29 and gender? It looks nice. It's actually looks like actually the call of a method. That's actually what I'm having here is I'm having just a constructor. Okay, the constructor will take as a parameter, takes three parameters in this case and initializes the corresponding actually variables, instance variables with the name, the age, and the gender, which corresponds actually to the formal parameters of the person. Now, the second one, instead of replicating it, I'm calling actually the constructor with three parameters. Unfortunately, once I will do it, Java will complain. Will tell you, oh, I'm having a problem. Okay, the problem is the following. Okay, if I have actually a person, in this case a call of a person, then I will go and look whether I have a method called person in this case. But I really do not have a method called person. Everyone will say, but I am having it here. I will tell you, this is not a method. We said it actually before, it's a constructor. Okay, and that's why Java will tell you, I'm sorry, you are not allowed to call a constructor by its name. The question is, but I would love actually to do it. I would love actually instead to repeat the three statements that I'm having in the body of the first constructor, which are actually the 3-1. I do not want actually to repeat them. Java will tell you there is another use of the this keyword. This of name 29 gender will mean that in this case I will be calling, let's say, the this keyword. Okay, I'm sorry, not the this keyword, the person constructor with 3 parameters, name, 29 and gender. And now once I will compile, Java will tell me I really don't have any problem because there is a constructor that expects let's say the first parameter to be a string, the second parameter to be an integer, and the third parameter to be a gender. In this case, a character. Thus, once I will compile and run it, Java actually will work perfectly, and we don't have actually any problem with that. Okay? Is this part clear for everyone? Okay. Thus, if I will go, okay, and I will define, let's say, another constructor person. Okay, and this constructor will have just actually the name. And what I want actually to do is, I want actually to define it as follows, that the name of the person is the one that changes. Okay, thus what I can do is, I can write this dot name is equal to name, and then this dot age is always equal to 10. And last but not least, this dot gender, I want actually only to create persons that are actually females in this case. Okay, is a female. Okay, it's one way how you will be able actually to use, let's say, the constructor with 1 parameters, where actually the frozen variables in this case are 2. Okay, thus the question is, what can I do? What I can do is I can create a third person. Thus the third person P3 is equal to new person in this case, and the new person is called Alia. Okay, and what I want actually to do is I want to write system.out.println to print actually information about Alia in this case, keeping in mind that Alia is having a name, an age, as well as a gender. Okay, thus once I will compile, if I didn't do any mistakes, then actually the whole thing will compile correctly. Once I will run, I will be expecting the name, the age, and the gender of Alia. In this case, Alia is 10 years old, and she is actually a female. Okay, thus, let me actually go back and take a look at the constructor. The constructor takes only 1 parameter, but here there is a problem that I'm replicating actually the code that I have actually done before. Thus, what I can do is, I can go and take a look at which constructor can I use in this case in such a way that the whole thing actually will work properly without actually replication. What I will do is, I will call the person with 3 parameters. The name is the one that I will pass. This is actually the variable that will change. The 10 is, let's say, the age, which is actually the frozen variable, and last but not least, a female in this case. I will be getting the same problem. Once I will compile, Java will tell me, oh, guy, you are having a problem. Okay, you are calling a person. The only thing that you can call by its name is a method. If you want actually to call a constructor, the constructor is called just either in order to create a new object, that means you need actually to write the new keyword, or if you want only, you don't want to create, but you want actually to, let's say in this case, to call the body of the method, you have to use the this keyword. Again, once I will compile and run, Java will tell me everything will be perfect. You get actually the same result. The name of the person will be, in this case, Alia. The gender is female. And last but not least, actually the age will be equal to 10. The question is, what would have happened if someone would have started with 10 and then name and then F? Java would get a problem. The question is this, meaning it's the constructor that is defined in the class itself. It's a person 1. And the question is, do I have a constructor that takes as a first parameter an integer, yes or no? Okay, Java will tell me I have never actually seen that actually before. And that's why what you will get here is, you get actually a problem that the name, okay, the first parameter should have been a string. However, actually what I'm entering is an integer in this case. Okay, now the question is, can I have, let's say, another constructor of the following form: string name, int age, and then char gender. even if actually the constructor is an empty one. Okay, once I will do it, Java will have actually one problem. Okay, and the problem is, I'm sorry, it tells you this type of overloading, I will not accept it. Why? Because you have already implemented the constructor with name, age, and gender. And what you are actually doing here is you are actually defining this constructor again. The same thing that we discussed actually about the overloading of methods will be applied on an overloading of constructors in this case. Thus, I will know exactly in this case, I cannot do it. The question is, can I do actually the following? Int age, okay, string name, and then char gender. In this case, Java will tell you, yes, I don't have any problem. Okay, now what can I do? I have actually two choices. I can use, let's say, the person one that I have already defined in order actually to avoid the replication. In this case, that's, look, I will call it with this. I will pass as a parameter name, and the second parameter is age, and the third parameter is a gender in this case. Okay, now the nice thing is, once I will compile, Java will tell me I really don't have any problem. Okay, why? Because I'm having actually two constructors, and I know exactly if someone will tell me person P is equal to new person 22, Ali, and M, I know exactly the first constructor is the one that will be used. Okay, I won't actually get confused. And if someone actually will write the following, person P is equal to new person Alia 22F, then I know exactly this constructor cannot be used because the first parameter is of type string. However, actually here, the one that I defined is of type integer. Thus, Java knows exactly there is only one single constructor that can be used, where the first parameter is a string, the second parameter is an integer, and the third parameter is a gender in this case. Okay? Good. Let's go further. Now, we saw, let's say, the difference between instance methods versus actually static methods. Now, what I want actually to do is, I want actually to find a way to keep track of the total number of persons I'm creating in my class. Okay, that's what I will do is, everyone will say, okay, I will just actually add a new variable C. Every time I will be creating my object, I will just increment actually my C by 1. Thus, I won't do it in the first one because I will do it here. Okay, I will be incrementing the C by 1. This name, age, and gender automatically will call the 4 parameters, meaning actually the C was already incremented by 1. This one, okay, if I will do it, let's say, with this implementation, then actually I don't need to repeat it. However, if someone would have done it with, let's say, the replication of this statement, what I need to do here is I have actually to increment the C by 1. Okay, and last but not least, the last one is just actually calling the this 10 name and F. Now, once I will go up, I see that actually the one that is having 3 parameters, where the first one is an integer and the second one is a string and the third one is a character, is calling actually the this. With this, the this is actually calling actually the body of the method where the C has been actually incremented in this case. Okay, now let's see what will happen actually in this case. Now, let's assume what I want actually to do is, I want actually to create, in this case, a person and keep track of the total number of objects I'm creating in this case. Now, what I will do is, I will write system.out.println, okay, and then I will be printing C. Okay, now once I will do it, Java will complain. Java will tell you, I'm sorry, the C doesn't actually have any context. Okay, now you have actually to understand it nicely. C is an instance variable, and an instance variable by definition actually belongs actually to the object, meaning any person that I will be creating, if I have a person, the person, let's say P1, will have in this case a name, an age, a gender, as well as a variable C. And if I will create a person P2, this P2 is having a name, an age, a gender, and a C. Why? Because I'm defining actually the C as an instance variable in this case. Okay, and that's why Java will tell you, I'm sorry, the C belongs actually to a specific, let's say, person. Okay, and that's why what I need to do is, I need actually to write p.c. Okay, I'm sorry, p1 actually dot c. Now, whenever I will compile, okay, whenever I will compile, this one actually will compile correctly. I don't have any problem with the context in this case. And the C دلوقتي is the instance variable that belongs actually to P1. That's actually, once I will do it, I need actually to C1 because actually I'm creating actually one object in this case. Okay, now I will be creating a second person. That's system.out.println. Okay, again, I will not be able actually to print the C without actually giving a context in this case. Otherwise, Java will complain. Why? An instance variable belongs always to, in this case, an object. The object is of type person. That's actually the question is p2.c. Okay, thus, just actually keep in mind, since C is an instance variable for an object, the default value of the C is equal to 0. That means every time you will go and you create an object, you will be incrementing a new variable C that belongs actually to the object in this case, because actually it's an instance variable. That means I really do not have actually a possibility in this case, let's say, to keep track of the total number of persons I'm creating. And last but not least, if I will take actually this one and then p23.c, okay, you will see that in this case you will be having 1, 1, 1, because every person will have now 4 instance variables. One of them is the name, the second one is the age, the third one is the gender, and the fourth one is a counter that should count the total number of objects I'm creating. And this one doesn't actually make sense at all. Okay, now let's go back. In Java, we want actually to distinguish between actually two things. Okay, things that belong actually to the object itself, and other things, okay, that belong to the class itself. And once I talk about things, here I mean variables or methods. Okay, thus, I really do not want actually to define attributes, but I want actually to define something we call class variables. Okay, in Java, sometimes we call them static variables. Okay, and look what I will do. I will just actually change the whole thing just by adding one keyword, which is called actually a static in C in this case. Okay, now look at what will happen. Now, once I will compile, okay, Java will tell me, okay, it's nice. This C that I'm creating here will be actually one single C, okay, that everyone will be able to see. Okay, that's once I create the first object will be having, actually is the first object. That means the total number of objects I'm creating will be 1. Okay, now if I will just create a second one, I display the C, then I will get it actually for the third time. Okay, and the question is it possible to call actually the C before, let's say, doing anything? I will tell you, since it's a static variable, what I can do is I can just actually pass, let's say, to the system.out.println the C as is, and what you will get here is 0, 1, 2, and 3. And just actually keep in mind, a static variable doesn't need any context. Any object will be able actually to see it, and that's why here you will be getting also 0, 1, 2, 3. Okay, any object will be able actually to see the value of this one. And in general, we do not need actually to call a static variable with the context, and that's why the way how this will be done actually will be done as follows. Once you will compile, this one actually will compile correctly. Once you will run, you will be getting a correct result in this case. Thus, the question is, if I want actually to have a method instead of writing system.out.println C every time, I want actually to implement a method that will return for me the C. Okay, that's what I will be defining here is a static method. Static method is a void one. It takes as a parameter nothing, it's a count. And last but not least, what it does is it just actually does a system.out.println, in this case, of C. And now, what you will see me actually doing here is, once I will go actually to the main method, okay, I will be just calling instead of system.out actually .println, I will be just calling here the count, okay, as a static method. It doesn't take any parameters. I don't need to invoke it on any method, okay? And that's why every time I will be creating, let's say, an object, I will be calling actually the count. I will call it for the third time. Okay, this is actually the count. And last but not least, once I am done with creating actually the fourth one, I will be actually calling the count. Okay, thus once I will compile, okay, the count is a static method. That means I don't need actually to invoke it on any object, and that's why Java will not complain. And once I will run, you will be getting exactly what will happen in this case. The C is like actually a clock. It's just a digital device. It exists only once in the class. Every time I will be creating an object, this count actually will be incremented by 1. And that's why the count in the beginning, my C is equal to 0. It's just actually a digital device that keeps track of the total number of objects I'm creating. Once I write a new person, then I will be creating an object. This is actually my first object, and that's why the first object will have actually the number 1. And then once I create a second object, then the total number of objects I created so far will be 2. And last but not least, after creating actually the third one, okay, the total number of objects I'm creating will be actually 3 in this case. Okay, nice. Now, we were actually sticking actually a lot to one example, and the question is, let's try actually to think about other examples in this case. Thus, what I want actually to do is, I want actually to create, let's say, a new class, and in the class, I want actually to define a point in a 2D space. Okay, thus, what I will do is, I will implement public static void main, okay, string args. This is actually the method that will be, let's say, the driver method actually to test my code. And now the first question that we have actually to ask ourselves, what are the attributes of, in this case, a point in a 2D space? You will tell me x will y coordinates. I will tell you, yes, it's correct. Thus, the first thing that you have actually to do is, you have actually to define, to declare the variable, meaning actually to give me the, let's say, data type of the x. Okay, let's do it actually with int x and int y in this case. Okay, now the question is it possible to now create a person point p is equal to new point in this case? Okay, you will tell me, I'm sorry, I really don't see any constructor with 0 parameters. However, once I will compile, Java will tell me I don't have any problem. Okay, what can I understand from it? Okay, now let's actually take it from the beginning. Any class that I define, okay, if I don't define any constructor, Java will include something which is called the default constructor. Okay, that's the default constructor will have actually the following form. Okay, point that doesn't take any parameters, and this one is an empty one, meaning the variables x and y will be actually assigned to what? Okay, will be assigned with their actually corresponding actually data types, and that's why once I will compile, this one actually will compile correctly. Now, once I want actually to know, let's say in this case, the x coordinate of p. Okay, for sure, any object, since actually p is a point, any object will have an x and a y coordinate. Now, once I will compile, Java will tell me, okay, it's nice, it's good. X is having actually a default value 0 because actually it's an integer in this case. And just actually keep in mind, if I would have actually changed this one into a double, okay, what you will be getting here is, okay, the data type is not an integer anymore, it's a floating point number, meaning actually the x will be equal to 0.0, which corresponds to the default value of a double in this case. Okay, now, just again, if I would have removed actually this one, everything actually will work perfectly. Okay, thus you will get actually the same result. Once actually you will print it, you will run it, then in this case you will get actually the 0.0. Okay, now let's think about first constructor. I will define the first constructor. Okay, I will define different actually constructors, but I will start, let's say, with the first one. Okay, the first one is a constructor that takes 2 parameters. Okay, thus let me do it as we did actually before. The point actually will take two parameters, x and y. You have to take care. Okay, now why? Because the formal parameters of the constructor are identical to the identifiers of the instance variables. And that's why here, once I will write it, I have to write this dot x is equal to x, and this dot y is equal to y. Now, please actually look at what will happen. I won't actually change anything in the main method. However, now, whenever I will compile, Java will complain. Okay, that it tells you, I'm sorry, I really do not find any constructor without any parameters. Few seconds ago, if we wouldn't have had that, if I would remove actually this one, Java wouldn't have actually complained. Okay, now what can we understand from that is the following. Whenever someone will define the constructor, the empty constructor will be gone. And that's why if you want actually to use it, the only choice that you will be having is just actually to create a constructor in this case, even if it doesn't actually have anything, Java will not complain anymore. That means instead of having only one constructor, we are having actually multiple constructors in this case. And what you can do is you can call this with, in this case, 0 and 0. If you want to do it with 1 and 1, this can actually be done in this case. And you have actually to see exactly what will happen if I have p.x plus space plus p.y. Okay, what will happen in this case? Once I will compile and run, okay, what I will be getting here is, okay, it's a semicolon. Now, once I will compile, this one will compile correctly. Once I will run, what I will be getting here as a result is 1.1 and 1.1. Why? Because I'm just actually passing the parameters here instead of repeating, let's say x is equal to 1 and the y is equal to 1. I will be just actually calling the other constructor in this case with this keyword, as you saw actually a few minutes ago. Anyone who will try to do it with point, Java will complain again. It tells you, I'm sorry, I'm trying actually to find a method which is called point that takes actually two parameters, but I don't see it here. You will tell me this is it, this is what I want actually to call. I will tell you the point is not a method, the point is a constructor. And the only way how you can actually solve the problem, if you want to call the body of the constructor but not create, let's say, a new object of type point, you have actually to do it with this keyword. Okay, thus, if I will have actually this one, I can actually write 9 and 4. And I will be expecting that everything will be working because actually the 9 is an integer, it will be transformed into 9.0. The 4 is an integer, it will be transformed into 4.0. And what will be displayed here will be actually 9.04.0. Okay, let me go, let's say, to the following statement. I will be writing system.out.println of p. Now, once I will compile, this one actually will compile correctly. Okay, and once I will run, I would love actually to see 9.0 and 4.0. However, I don't get it. And the main problem is that here in this case, I'm missing actually a toString method. Okay, that's Java, whenever it sees, let's say, a system.out.println of something, it invokes a toString method on it. Now, once I will do it, the toString method, which is predefined in Java in the object class, okay, will just actually return for me the reference. It tells me the P is of type point, and this is actually the reference where it is stored, the memory location where it is stored. Okay, thus, what I want actually to do is, we want actually to override it. Thus, the way how actually the whole thing will be done is to implement a method which is called toString, T lowercase, S uppercase. And this one, what it does is, it returns the x plus, in this case, space plus y. Okay, now, once I will do it, Java will tell me, okay, I see a method, which is an instance method that is actually invoked on an object. And now this method is overridden. Okay, and that's why once I see p.toString, okay, the toString method that will be called is the one that is defined in the class point. And this one will give me the x and the y coordinates in this case. Okay, thus, what I will do is, I will go and remove actually this one. And I said it actually before. If you do not write actually the dot toString, Java will do it for you. And that's why in this case, you don't get the reference anymore. Why? Because the Java sees a toString method and automatically it will invoke on the P the toString method before actually printing actually the statement in this case. Okay, thus let's go, let's say, to implement actually some of the methods. This is actually the first method, which is an instance method. Okay, thus it's an instance method that we have implemented. Now the question is it possible to implement a method that moves, let's say, the point by dx and dy? Okay, thus I will implement a method, it's a void one, it's called move. It's an instance method, it will be invoked on an object, and it takes a double, let's say, dx, okay, and a double dy. Thus, I want actually to move a point by dx and dy. The x will be actually moved by dx, and the y will be moved by dy in this case. Okay, now what I can actually do is the following: x plus equal to dx, okay, keeping in mind that in this case the x is the x of the object I will be invoking the method on. There is no need to write it because it is used only once. And the second one is y plus equal actually dx in this case. Okay, thus once I will go here, I will be printing actually the p, and then I will be using actually the move, okay, by let's say 1 and 1, okay, and this move operation, since it's an instance method, it has to be invoked on an object of type point, is p.move 1 1. And last but not least, I will take, let's say, the whole statement and I will print it again, just actually to see, let's say, the effect of the method. Now, the method actually will be invoked on P just by moving 9 by 1 and the 1 by 1. That means in this case, you will be getting 10.0, 5.0. Okay, thus, this is, let's say, a method that doesn't actually return anything, but actually the effect will be seen on the method itself. Okay, now the question is it possible to return actually the point itself? I will tell you, yes, you can actually do it. But the question is, what do you want actually to return? You will tell me, I would love to return the object that the method will be invoked on. What's its name? As we saw it in the compare method, the name of it is this. At the end of the day, you get actually the same result. Okay, thus here I'm returning the this corresponds actually to the object that I am actually changing, which is the same object that I'm actually having, and that's why, okay, the same statements actually will work. I don't have any problem. The only actually difference is that I can actually take a point, let's say P2, and write actually that the point P2 is equal to P.move of 1 1. Thus, in this case, this one actually will work. And if I will print actually the P, you will get in this case 10.0, 5.0. And if you will print P2, because these are actually two references in this case, and the two references are pointing actually to the same thing, what you will be getting as a result here is the same, which is 10.0, 5.0. Here you have actually to know if I will take actually the P.x equal to 22, and you want actually to print the P2 after it, since actually the two pointers are pointing actually to the same memory address. Anything that you will be doing with the P2 will see it. Everything that the P2 will do, the P actually will see it, as we saw last time in the first lecture about classes and objects. Okay, nice. Let's move on. And let's take a look at the following changes. Now, what I want actually to do is, as we did before, I want actually to keep track of the total number of points I'm creating. That's actually what you will do is you have actually to define, let's say, some of, let's say, the static variables. I will define only one. I will call it actually C. Okay, and the question is, okay, since it's a static variable, I need actually to add the static keyword in this case. Thus, just actually keep in mind actually to repeat myself. Okay, for every object you will be creating, two attributes X and Y will be created actually for the objects of type point. However, for the whole class, and that's why this one actually is called also a class variable, there will be only one variable that will be created actually for the whole class. Okay, now what should I do with the C? Okay, I should actually update the C whenever I will be creating an object in this case, and that's why I will do it here only once. Okay, C++. Okay, here, once I create the point and once I initialize the x to be equal to this dot x and the y to be equal to this dot y. However, here I won't do it because the this of 1, 1 will be calling actually the body of the method with the 3 statements. Thus, actually the C will be incremented actually by 1 in this case. Okay, thus, the question is, what can I do now? Okay, what I can do is I can write system.out.println. Okay, and what I will be printing here is the C. Okay, now what I can do is I can take actually this one, and after creating, let's say, the second point or the first point, I will actually, let's say, print it again. And that's why at the end of the day, the total number of points will be 1. Okay. And if I would have actually gone to create another point, okay, I will have point P3 is equal to a new point without anything. Okay, since I have a constructor that does that, okay, the system.out.println of C will be giving me, let's say, the total number of points I will be creating here in this case. Okay, thus the C, the first C will be equal to 0, second one will be equal to 1, and the third one actually will be equal to 2. Please actually take care. I am really not allowed actually to have this and then create, increment actually the C by 1, because once you will do it, okay, the second point that you will be creating will be calculated, will be counted twice. That means you will be having 0, 1, 3. Okay, although the total number of points I'm creating are only 2. Okay, it's point P, and this one is point P3. These are actually the only points I'm creating. And the main problem is that the constructor in this case, okay, it's calling the constructor that already increments the C by 1, and you are having a replication of incrementing actually the C by 1 in this case. Okay, this one will work. This is actually a point class. And now we want actually to go further. Since actually we are having classes, I will go and create a new class, and the new class will be called circle. Just for information, once I do it actually with JCreator, JCreator will automatically include for me the default actually constructor. Okay, guys, I will keep it, and then what I will do is I will define now a main method that I will be testing in this case, string args. Okay, and now what I want actually to do here is the following. I want to think about how a circle is defined in general. Okay, thus what are the attributes? Okay, now everyone knows that a circle is defined by two things. Okay, first of all, by the radius and its center. Thus, the radius will be double r. And the center is what? The center is a point. And that's why what I will do is, I will replicate double x, double y. Now, instead actually of doing that, okay, the question is it possible to use a class that we have already defined before? Okay, thus instead of writing double x, double y, where the x corresponds to the x coordinate of the center of the circle and the y corresponds to the y coordinate of the center of the circle, because actually if I will compile that, Java actually will not complain at all. It tells me I don't have any problem. But instead of doing that, okay, I will just actually define the circle with, let's say, two instance variables. One of them is the r, which corresponds to the radius, and the second one is the point, which corresponds point C, which corresponds actually to the circle. Okay, thus let me go and implement, let's say, few constructors in this case. Okay, the first constructor has been implemented actually for us, has been included automatically, let's say, for us. Now we will define a second one. The second one could be one that takes 3 parameters. First one is double x, double y, and last but not least, double r. Okay, thus the x will y corresponds to the x and the y coordinates of the point, which is actually the center. Thus I will be creating the C. Here I'm declaring it, here I'm creating it. C is equal to new point of, in this case, x and y. Okay, and the this dot r, okay, this one actually I can write this dot c, but since actually there is no conflict, I will be writing actually this dot r is equal in this case to, okay, r, okay, is the parameter that I'm passing is equal actually to, let's say, the instance variable of the object I will be creating in this case. And now let's go to the main method. What I can do is I can define now a circle. The circle will be called C is equal to new circle that takes in this case 1, 2, and 3 in this case. Meaning this center is having an x coordinate 1, a y coordinate 2, and a radius of 3. Now the question is, let me write down system.out.println C. Okay, now let's do it step by step. If I write system.out.println C, Java actually will see the following. Okay, we'll see that the object that I will be creating is, in this case, the circle. Okay, thus, once I will compile, this one will compile correctly. Okay, and once I will run, Java will tell me, I'm sorry, I don't see a toString method in the circle class, and that's why what you will be getting here is the reference. Reference is of type circle, and what you will be getting here is, you will be getting a memory address where the object actually will be stored. Now, let me write actually the following, C.C. The first C is the circle, the second C is the center. And now you go up and you see that actually this one is of type point. Now, it depends on the point class. If the point class is having a toString method, I will be expecting here as a result, okay, the display of 1.0 and 2.0. Now, once I will compile and I will run, what Java actually will tell me here is the result actually will be 1.0 and 2.0. Now, if I will go to the point class and I will remove the toString method, I will compile this one, and then I will go to the circle, okay? Thus, what you will be getting here as a result is, okay, C.C is of type point, and it's stored in a specific memory location in this case, okay? Thus, it has actually something to do with what I have in the class, let's say, point. Now, the question is, what if I want to see the x-coordinate of the center of the circle? Read it actually please backwards. X is the x-coordinate of the center of this circle. Thus, in this case, what I should get here is, I should get the 1. And what you get actually as a result is the 1. Okay, now, last but not least, if I want actually to get the radius, okay, it's the radius of the circle, okay, I don't need actually to write C.R because actually a point doesn't have actually a radius in this case, that's R, okay, C.R, in this case, once I will compile and actually I will run it, what you will be getting here is, you will be getting as a result, in this case, the 3.0. 3.0 corresponds actually in this case to the variable in this case. Okay, 3.0 corresponds actually to the radius of the center in this case. Okay, R, it's the radius of the circle. Okay, now, let's move on and let's think about actually the following. What I want actually to do is, I'm having, let's say, a new constructor that I want actually to create. Okay, let's go actually to another constructor. The constructor will expect two coordinates, two parameters. The first one is a point. I will call it point C. And the second one is a double R in this case. Okay, thus this one will have actually the following body. This dot C is equal to C. And last but not least, this dot R is equal to R in this case. Okay, now let's go and just take a look at the following. I will be creating a point P2 or P is equal to new point of 5 and 5. Okay, then I will be creating a new circle. I will call it circle C2 is equal to new circle of, and now what I will be doing here is I will be passing actually the p as a parameter, and the radius is 1.5 in this case. Okay, and what I want actually to do is I want actually to print, let's say, the C2. Once I will compile, Java will tell me, okay, I don't have any problem. The C2 is a circle that is created with a constructor that corresponds actually, that is having actually 2 parameters. Now, once I will run it, what you will be getting as a result in this case is the reference, because I'm printing actually the C2 because there is no toString method. Now, if I want actually to get the center of C2, I will be writing C2.c. Okay, read it is C. It corresponds actually to the instance variable. Okay, okay, C, in this case, C2.c is the center of C2. Now, since actually the center of C2 is a point and there is a toString method in this case, I will be getting 5.0 and 5.0 as a result, which corresponds actually to these parameters. Now, the question is, I would love, let's say, to take a look at, let's say, the call of I want actually to implement a toString method in the class actually circle. Okay, it's a public string, toString, and I really do not want actually to have now, let's say, the constructor in this case, okay, the reference in this case, but I want actually to get the parameters, the x, the y, as well as the radius in this case actually displayed. Okay, that's what I will do is the toString method will be invoked on a circle. The circle is having a center. Okay, the center is a point, and that's why what I will do is I will call, let's say, the toString method on C. Okay, and what I will do is I will add actually to it, since actually it's a string, I will add actually to it the R in this case. Okay, thus once I have that, what will happen in this case once I will compile? Okay, this one hopefully will compile actually correctly, and once I will run, I want actually to get the 5.0 as well as the 1.5 actually displayed, and you get actually 5.0, 5.0 and 1.5. The C2 string is calling the toString method on C. What is actually the C? The C is of type point. And last but not least, once I will have, let's say, I concatenate it with the R is the radius of the circle in this case, and in this case you are having a toString method that will actually display for you information about the x and the y coordinates by using actually the toString method that has been defined in the point class. Okay, now I would love to find the total number of points I'm creating in this case. The question is how can I do it? Here I am actually seeing 1 point actually created with point P equal to new point. However, if you take a look at circle C is equal to new circle, then in this case you go up and you see that actually in the circle you are actually creating a new point. That means actually what I want actually to have at the end of the day is the total number of points created in the circle class. Now, unfortunately, once I will have that, I don't get actually anything except actually the information about the C, because Java doesn't see the C of the point just actually by writing actually C in this case. Okay, now the question is, what do you want actually to display here? Okay, thus, let me go actually to the point and let's take a look at, let's say, the class variable in this case. The class variable, which is the static variable, is called C. The C belongs to the point class, and it's a class variable. Thus, the way how you will be able actually to see it is just actually by writing point.c, meaning here, give me the class variable that is defined in the point class. And what I will be expecting here as a result is 2, okay, because I am creating actually 2 points, one of them actually through the circle 1, another one I'm creating actually directly in the main class, okay, with the point 1. Now the question is, if this is the case, does the point P sees, does the point P see actually the variable, the instance, the static variable C, yes or no? And as we saw before, for sure actually the point actually sees also actually the total number of points that are created, yeah, that means you are getting actually the same result. However, here the nice thing is once you do it actually with the point, you can actually call it whenever you want, even if you haven't actually created anything before. Okay, that's if I will do it in the beginning point.c. In this case, what you will be getting here is, okay, Java will tell you, I really actually don't have any problem. Okay, thus you want actually to see the total number of parameters, okay, of points that you created. I haven't created any point actually here. I have 0. After creating a first circle and the second circle, there are actually 2 points that have been created, and that's why the total number of points is equal actually to 2 in this case. Okay, enough for today. I wish you, let's say, a safe stay. Please stay home, stay safe, and just try to practice as I was always actually encouraging you to do it. Try to solve as many problems as possible, and hopefully we will see each other soon at the Jam University in Cairo. We will keep in touch, and please stay safe.